Logic gates are at the heart of how we build complex digital circuits. Logic gates and constructing them and combining them, both in hardware and in software, we are able to perform complex computational functions. They don't operate individually necessarily nowadays, but you can have hundreds and thousands upon thousands of these in a single circuit in order to perform, you name it. But having a good understanding of the basic logic gates will go a long ways when you're learning how to either construct hardware or program software. I want to cover 7 basic logic gates in this video. First one being the NOT gate. The NOT gate is an inverter. It's very simple. It takes one input, and then it has one output. And the output is simply the inverse of the input. So if we look at a truth table, this is the symbol for a NOT gate. Just a triangle with this little circle on the end. This is our truth table. Very simple. If we take a 0 input, or false, we will get a 1 output, or true. Likewise, if we take a 1 input, or true value, we will get a 0 output. We can test this using a Python script. Here is our function. If a is equal to 0, return a 1. If a is equal to 1, return a 0. And we do so down here using these print functions, and we make the 2 calls. So if we run this, we will see when a is 0, the output is 1. And when a is 1, the output is 0. The remaining logic gates all have 2 inputs, starting with the AND. With the AND, and these are just kind of my notes, by the way, off to the side here of an easy way for me to remember what each logic gate does. So in order to get a 1 or true output, what must happen with this logic gate? In the case of AND, must be, the way I wrote this is crazy. Both of them have to be true. So both of the inputs need to be true values in order to get a true output. If we look at the truth table, we can see this is the symbol for AND, the AND logic gate. And in order to get a true, there's 4 different possibilities here, but in order to get a true output, both inputs have to be true or a 1. If you have any false true combinations, you will get a 0 or false output. In Python, we can see this as well if we run this simple script here. We can use the AND keyword here in Python. Makes it very simple, saying the only time we will return a 1 value is if both of the inputs are 1. The next logic gate is OR. As the name would imply, if you have either inputs as true or both inputs as true, you will get a true output. This is the symbol for an OR logic gate. And as you can see, there's 3 outcomes with a true value. So if you have at least 1 true input, you will get a true output. as can be seen here in our Python script. In this case, we used an if-elif statement, just indicating if we have a 1 in either position, we will get a 1 output. The exclusive OR, again, the names of these tell you a lot. It must exclusively be either or, which means both values cannot be true. Looking at the symbol here, this is the symbol for exclusive OR. You only have two different situations where you can get a true output. If you have 2 false or 2 true inputs, you will get a false output. However, if you have at least one, but not both, just one true input, you will get a true output. And this can be seen here in our Python code. Again, in this case, we're using a not equals to statement to make that determination for us. If the A input is not equal to the B input, meaning they're both not the same, we should get a 1, we will get a 1 output. And that can be seen down here. The 5th logic gate is the NAND, or negated AND logic gate. The way you can think about these, anytime it has an N tacked onto it, it's a negated AND. It's going to do the opposite of what an AND gate does. So in this case, of our NAND gate, as you can see, if we have 2 true inputs, we will get a false output. That's the exact opposite of our AND gate. So in this case, we'll get a true output as long as we have either 2 false or 1 true value. And the symbol is here, again, with a little circle on the end of the AND gate to indicate it's negated AND. And here we can see if A is equal to 1 and B is equal to 1, return a 0, else you get a 1. And that is your NAND logic gate. We also have a negated or NOR, where you must not have 2 false inputs in order to get your true. And all that means, or excuse me, I said that. Interesting. So you must have 2 false inputs to get your true output. Otherwise, if you have 2 trues or 1 true input, you will get a false output, which is, again, the opposite of what we saw with our OR logic gate. And this is the symbol for our NOR logic gate. We can see it here in our Python code. Now for this one, we did an if-elif for each situation to ensure we got the proper output. So in this case, if A and B is equal to 0, that's how we would get our 1. Otherwise, if you have a 0 and a 1 and a 0, or 2 1 inputs, you should get a 0 output. The last one to cover is our exclusive NOR. Must be either or, but not both, to be true. And all that's going to tell us, that's not the right one. That's going to tell us that, again, the exact opposite of the exclusive OR, in this case is the exclusive NOR, is, and this is the symbol for it, we must have a input of 2 falses or 2 trues in order to get our true output, which can be seen here as an example in our Python code. If A is equal to B, return a 1, which means so it's very simple. If they're the same, return a 1, else return a 0.